Look at this, right here on my finger. This is a single grain of salt. If I drop it on the floor, it's gone. It's irrelevant. It has literally zero aura. Now, I want you to imagine that this grain of salt is the Earth, our entire planet. Every mountain, every ocean, every single person who has ever lived, every embarrassing text you've ever sent, every W and every L in human history shrunk down into this microscopic, crunchy little cube. If Earth is this grain of salt, how big do you think the Sun is? Maybe a basketball. Nah, you're not even close. If Earth is this grain of salt, the Sun is a literal wrecking ball sitting inside your bedroom. But wait, we're just getting started. Because if the Sun is that wrecking ball, how far away is the nearest star? Not the edge of the universe. Just the house next door in our cosmic neighborhood. If the Sun is a wrecking ball in your room, the nearest star is another wrecking ball sitting in a city 4,000 miles away. And the space between them? Completely, absolutely, terrifyingly empty. No cap, the universe is so unhinged, so disgustingly massive, that our human brains physically lack the hardware to comprehend it. We are basically NPCs trying to render a map that has no boundaries. Today, we are going to break your brain. We're zooming out all the way to the edge of the observable universe, and I promise you, by the end of this video, you will realize that reality is completely cooked.
Hey, welcome back to MindSpark, the place where curiosity comes alive. Let me ask you something. Have you ever wondered what would happen if things suddenly changed instantly? Stick with me, because the answer is way more shocking than you think.
What is up, guys? Welcome back to MindSpark, the only channel on the internet that gives you a daily dose of existential dread but makes it aesthetic. If you're new here, smash that subscribe button, hit the bell, and buckle up, because today we are talking about scale. The true, terrifying, mind-blowing scale of the cosmos. Look, we all know the universe is big. Your science teacher in 6th grade probably showed you a poster of the solar system and was like, "Wow, space is vast, guys." But those posters lied to you. They are mathematically invalid. If those posters were drawn to scale, you would need a piece of paper the size of a whole continent just to fit Jupiter on it. The reality is, the universe is giving heavy final boss energy, and we haven't even unlocked the tutorial yet. We live our lives thinking our world is huge. You fly from New York to Tokyo, it takes 14 hours, and you step off the plane feeling like you just crossed infinity. Your legs are cramped, your back is cooked, and you're complaining about airplane food. But on a cosmic scale, you didn't even move. You literally stayed in the exact same spot. In this video, we're going on a road trip. We're starting right here on Earth, and we are zooming out. Past the moon, past the solar system, past our galaxy, straight into the absolute void of the cosmic web. We are going to scale up chapter by chapter, and I'm going to use real, everyday objects to prove to you how absolutely tiny we are. The math is real. The physics are real. Let him cook me, I'm him. I am cooking right now because we are about to journey to the edge of reality. Bet, let's go. All right, let's start small. The moon, it's our closest neighbor, our ride or die. It looks like it's right there, right? Like you could just reach out and grab it. When you look at the moon in the night sky, it has serious aura. It controls the tides, it gives us eclipses, it's a total W for planet Earth. This is how we think about the Earth and the moon, right next to each other. Besties, but this is cap. The average distance between the Earth and the moon is about 238,900 miles. That's 384,400 kilometers for my metric system legends. To put that into perspective, if you got into a car and drove at a constant speed of 60 miles per hour without ever stopping for gas, snacks, or bathroom breaks, it would take you nearly 6 months of continuous driving to reach the moon. Bro, you'd be legally insane by the time you got there. But here is the fact that is going to make you realize we are already cooked. You can fit every single other planet in our solar system into the empty space between the Earth and the Moon. I'm dead serious. Let that sink in. Jupiter is an absolute unit. It's so big you could fit 1,300 Earths inside it. Saturn is so wide its rings could stretch from the Earth to the Moon almost entirely by themselves. And yet, you can take all these gas giants, all these rocky worlds, line them up like a cosmic conga line, and they perfectly fit in the gap between us and our closest neighbor. And that is just our front porch. That is step one. We haven't even left the driveway yet, and the distances are already making my brain glitch. We are stuck on a tiny rock, thinking we are the main characters of the universe, when in reality, we barely take up any storage space on the server. So we've made it to the Moon. Cool. Now let's talk about the boss of our system, the Sun. The Sun contains 99.8% of all the mass in our entire solar system. Everything else, Jupiter, Earth, all the asteroids, all the comets, your car, your house, your dog, makes up just 0.2%. The Sun is basically hoarding all the matter and leaving us the crumbs. Talk about greedy. Let's do another scale check. Let's shrink the Sun down to the size of this tennis ball. Valid, right? If the Sun is this tennis ball, sitting right here in my hand, where is the Earth? The Earth is this microscopic speck of dust, and it would be orbiting the tennis ball from about 24 feet away. That's across the room. But what about Neptune, the furthest actual planet in our solar system? If the Sun is a tennis ball in my hand, Neptune is a slightly larger grain of sand sitting about 700 feet away. That's over 2 football fields of completely empty, freezing, dead space. And this is where we have to talk about human engineering, because we actually sent something out there. Let him cook for a second. Voyager 1. Launched in 1977, it is the fastest, furthest human-made object ever created. It is currently zooming away from us at roughly 38,000 miles per hour. That's 10 miles every single second. At that speed, you could cross the entire United States in less than 5 minutes. That is maximum WRIS for NASA. Voyager 1 has been flying at that unhinged speed for almost 50 years. 24/7, never stopping. And guess what? It just barely left our solar system. It's barely in interstellar space. It's roughly 15 billion miles away. It takes light itself, the fastest thing in the universe, 22 hours just to travel from Earth to Voyager 1. If you sent a text to Voyager, you'd be left on read for 2 entire days before you got a reply. The ultimate ghosting. But here is the wildest part. Even at 38,000 miles per hour, if Voyager 1 was pointed directly at the nearest star to our solar system, Proxima Centauri, it wouldn't get there for 70,000 years. Let me repeat that. 70,000 years. Our fastest ship is practically standing still compared to the vastness of the void. We are trapped, bro. We are geographically cooked. Okay, take a deep breath. We are leaving the neighborhood. We are zooming out to the city level. This is our galaxy, the Milky Way, a swirling disk of gas, dust, and stars floating in the dark. When you look up at the night sky and see stars, you probably think you're seeing the whole universe, right? Delulu. Absolutely Delulu. Every single star you have ever seen with your naked eye, every constellation, the Big Dipper, Orion's belt is located inside a tiny, localized bubble in one minor spiral arm of this galaxy. You see this little circle? That's our entire night sky. The rest of the galaxy is completely invisible to you without a telescope. And how big is this galaxy? Let's go back to our analogies. Let's shrink our entire solar system, the Sun, Earth, Neptune, and the massive 15 billion mile void that Voyager 1 is flying through. Let's shrink all of that down to the size of a standard US quarter, a 25-cent coin. If our entire solar system is this quarter, how big is the Milky Way galaxy? Is it the size of a room, a football stadium? If the solar system was a quarter, the Milky Way galaxy would be the size of the North American continent. Think about that. You could take your little quarter, drop it in a forest in Canada, and the rest of the galaxy stretches all the way to the beaches of Mexico. Inside this absolutely majestic, terrifying structure, there are an estimated 100 to 400 billion stars. And modern astronomy tells us that almost every single one of those stars has planets orbiting it. Trillions of planets, trillions of alien sunsets, trillions of oceans, maybe some with life, just vibing, completely unaware that we even exist. This is the part where you have to stop and touch grass. Because statistically, there is absolutely no way we are alone. With hundreds of billions of stars just in our local city, the idea that Earth is the only place with life is astronomically sus. We are NPCs in a galactic open-world game, and we haven't even figured out how to leave our spawn point. But wait, you didn't think the Milky Way was the biggest thing out there, did you? Oh no, no, no. We need to talk about what happens when galaxies get hungry. We need to talk about the monsters lurking in the dark. Our galaxy is big, but in the grand scheme of things, it's just one house in a massive, sprawling cosmic suburb. Welcome to the local group. A cluster of about 54 galaxies, including our big sister, Andromeda. By the way, fun fact. Andromeda is currently hurtling toward us at 250,000 miles per hour, and in about 4 billion years, our two galaxies are going to smash into each other in a colossal cosmic train wreck. So, mark your calendars. But let's zoom out further. The local group is just a small part of the Virgo supercluster, and the Virgo supercluster, it's just one tiny branch on an even bigger structure. A structure so massive that scientists named it Laniakea. In Hawaiian, Laniakea translates to immense heaven. And honestly, that name is so valid. Look at this. This isn't CGI from a sci-fi movie. This is a real, scientifically mapped rendering of our local corner of the universe. Every single tiny speck of light in this structure is not a star. It's a galaxy. Laniakea contains approximately 100,000 galaxies. That is 100,000 Milky Ways, stretching across 520 million light-years of space. But here is where things get genuinely unhinged. If you map the movement of all 100,000 galaxies in Laniakea, you'll notice something terrifying. They are all moving like water flowing down a drain. They are all being pulled by a gravitational force so unimaginably powerful that it dictates the movement of millions of light-years of matter. Scientists call this gravitational anomaly the Great Attractor. Bro, the Great Attractor is the ultimate final boss. It's an area of space packed with so much mass, tens of thousands of times more massive than the Milky Way, that it's dragging everything toward it, including us. The Milky Way is being pulled toward the Great Attractor at a speed of 1.3 million miles per hour. And the scariest part? We don't even know exactly what it is. Because it sits exactly behind the zone of avoidance, a dense band of gas and dust in our own galaxy that blocks our view. It's like the universe literally put up a sensor bar over the scariest monster in the game. It has infinite aura, and it's pulling us in rent-free. All right, we are pushing the limits of the human brain now. Let's zoom out one final time. From Laniakea, we pull back to see the entire observable universe. This is it, the big picture, the cosmic web. When you zoom out this far, individual galaxies don't even matter anymore. The universe looks like a sponge. Massive, glowing filaments of dark matter and galaxies, separated by unimaginably huge, empty voids where practically nothing exists. The observable universe is a sphere that is 93 billion light-years in diameter. Let that number hit you. Light, moving at 186,000 miles per second, takes 93 billion years to cross this space. Inside this sphere, astronomers estimate there are up to 2 trillion galaxies. Not stars, trillions of galaxies, each one packed with billions of stars, planets, and moons. If you took every single grain of sand on every single beach, on every single coastline across the entire planet Earth, there are more stars in the observable universe than there are grains of sand on Earth. Think about the last time you went to the beach. Think about picking up a handful of sand. Thousands of grains in one hand. Now multiply that by every beach, every desert, the bottom of every ocean. The stars outnumber them by a lot. We are not even a grain of sand. We are the microscopic bacteria living on a single atom on a grain of sand, floating in a cosmic ocean that is so big, it breaks the laws of human comprehension. And you're stressing because someone left you on read? Bro, you need to look up. You need to let the universe cook, because your problems are literally subatomic on this scale. But wait, I used a very specific word just now. I said the observable universe, which implies there's an unobservable universe. And that brings us to the final, most terrifying reality check of this entire video. Why do we call it the observable universe? Because the universe has a speed limit, the speed of light. Light takes time to travel. When you look at the sun, you are seeing it as it was 8 minutes ago. When you look at the nearest star, you are seeing it as it was 4 years ago. When you look at the furthest galaxies with the James Webb Space Telescope, you are looking billions of years into the past. You are literally looking back in time. Because the universe is roughly 13.8 billion years old, light has only had 13.8 billion years to travel to us. That creates a physical bubble around Earth. A horizon. Anything beyond that horizon, the light simply hasn't had enough time to reach us yet. But because the universe has been expanding and expanding faster than the speed of light, that boundary is now 46.5 billion light-years away in every direction, giving us our 93 billion light-year sphere. But what is beyond that boundary? What is outside our 93 billion light-year bubble? The answer is more. A lot more. And this is where scientists just throw their hands up and realize we might be eternally cooked. Based on the geometry of the cosmos and the study of cosmic background radiation, cosmologists estimate that the actual, total universe is at least 250 times larger than the observable universe. Imagine taking our 93 billion light-year sphere, a sphere containing 2 trillion galaxies, and realizing it is just a tiny drop in an ocean that is 250 times bigger. And that's the conservative estimate. Many physicists believe the universe doesn't have an edge. They believe it is infinite. Forever. No walls, no boundaries, no ending. Just an endless expanse of galaxies, stars, and voids stretching out into mathematical infinity. If the universe is truly infinite, that means every possible physical reality that can exist does exist. In an infinite space, matter can only arrange itself in so many ways before it has to repeat, which means, mathematically, there could be another Earth out there, millions of light years away. There could be another you, sitting there watching this exact video, but maybe you have blue hair instead of brown. Maybe you actually studied for that test instead of scrolling YouTube. Infinity is a glitch in the matrix. It means nothing matters, and yet everything is possible. Man, I don't know about you, but I need to go lie down. We went from a single grain of salt to the moon to a giant tennis ball sun, across a continent-sized galaxy, straight into the maw of the Great Attractor, and out into an infinite, repeating multiverse. The real size of the universe is absurd. It's hostile, it's cold, and it's mathematically unhinged. But honestly, I think it's beautiful. We are just a bunch of talking apes on a rock floating in infinity. The universe is massive, but as far as we know, we are the universe experiencing itself. We are the only part of this giant, trillion galaxy void that can actually look up and say, "Wow, that's crazy." Our brains might be tiny, but they hold the capacity to comprehend infinity. And that, my friends, is ultimate WRIZ. That is main character energy. If your brain is officially cooked and you learned something mind-blowing today, do me a huge favor. Smash that like button. It takes you 1 second, and it absolutely feeds the YouTube algorithm so we can keep making these massive videos. Drop a comment down below right now. What was the craziest, most mind-blown moment of this video for you? Was it the planets fitting between the Earth and the Moon? Or was it the Great Attractor pulling us into the void? Let's argue in the comments. I'll be down there replying to the absolute best ones. Make sure you are subscribed so you don't miss our next deep dive into the cosmos. Until next time, keep looking up, stay curious, and remember you are mathematically nothing, but you are still awesome. MindSpark out.
If this video made you think even for a second, hit the like button. It really helps the channel. Subscribe to MindSpark for more mind-blowing ideas, and tell me in the comments what topic we should explore next. Until next time, keep your mind curious,